Thank you for joining me to discuss the ins and outs of each of the science and engineering practices. My name is Eddie Walsh, and I want to start us off by having us consider a phenomenon you could explore if you were discussing light and its properties with your students. And just as I would pose it to my students, I would pose this direction to you now. What do you notice, and what do you wonder about the diagram phenomenon you see in front of you? And rather than trying to fill the silence with additional leading questions, I'm going to give you just a moment to consider this. What do you notice? What do you wonder when you see this phenomenon demonstrated for you in this way? Were we in a classroom, I would ask you to share out your notices and wonders and tell each other how you came to consider the questions you came up with. In this case, students would hopefully notice the curvature of the beam of light being emitted by a far-off star, and realize, based on the diagram, that stars in the sky are not where they appear to be. Questions may circulate around the differences between the sun and Earth, even the star. Students may consider the beam of light and how it causes stars to appear in different locations. Students may consider the stars themselves and wonder how they came to be and how they work. Reflecting on this notice wonder activity, we have allowed students produce questions and observations about a phenomenon without binding them to the obvious question. Students now have the opportunity to develop their own questions and curiosities related to the phenomenon. Some questions directly address the standard that you may be teaching at the moment. Some don't, but students now have more stake in the investigation. It's important to recognize asking questions and defining problems are both skills that are used to generate and lead inquiries. Not all students are equipped with a sense for asking questions, and while it may be faster to divide the questions for students to investigate, as teachers, we can often deprive our students of the knowledge gained in the question-making phase of a scientific investigation. It is important to set aside time and teach students strategies related to questions and problems. So much so, we adopted it into our Idaho Science Standards. I want to go ahead and fully introduce myself. My name is Eddie Walsh, and I'm the Region 6 Instructional Science Coach working with the Idaho Department of Education. I am based out of Idaho Falls, but myself and the other Idaho Science coaches are happy to meet you wherever you are in your science education journey. Our sole focus is to help teachers plan, teach, and assess around the Idaho Content Standards for Science. I want to take this opportunity to focus on how we can approach the science and engineering practice of asking questions and defining problems. If you have further questions about how the Idaho Science coaches can help you with your teaching goals, feel free to reach out to me at my email or visit our Idaho Science Coach website via the QR code or Idaho Department of Education website. When the National Academies of Science, Engineering, and Medicine developed the 3 dimensions of the framework for K-12 science education in 2011, the science and engineering practices were recognized as perhaps the largest shift educators would need to address to engage students in the immersive experience that is science. Asking students to develop questions like scientists means giving students a breadth of interactions with a range of phenomena and allowing them to generate questions surrounding the entirety of the phenomenon they have observed, not just the parts you want them to focus on. As engineers, it's important to understand questions may produce more than one right answer, especially when searching for solutions to solve problems. I would make it my recommendation right now, if you can, lead with an opportunity for students to generate questions independently. Do it as often as you can. While students may initially find coming up with their own questions to be difficult and time-consuming, with frequency and practice, students will be able to find questions in more challenging situations. Questions from the past not only give us a perspective on how far we've come, but also what questions we have developed for ourselves over time. Isaac Newton's understanding of physics led him to develop questions about gravity in the 1600s that we still consider today, especially as we launch satellites and consider mechanisms for intergalactic travel. Einstein's question, what would happen if I rode a beam of light, allowed him to adopt the appropriate lens needed in order to develop the theory of special relativity. Marie Curie used the observations of her mentor, who was researching uranium just as people were trying to understand what radiation was. Her curiosities led her to discover 2 elements, radium and polonium, and methods for using radioactive materials in medicine. By asking questions like these, scientists confront what they do not know and use the resources at their disposal to create verifiable investigations that answer questions surrounding their original gaps in knowledge. It can be crazy to think that we once believed Earth was the center of our universe, but it's pretty incredible to know that questions were what brought us to our modern understanding of space, gravity, time, and everything else. Integrating the science and engineering practice of asking questions and defining problems needs to look differently at each step in the K-12 student experience. We as teachers and administrators recognize when one grade band or another doesn't provide students opportunities to advance in their question creating skills, we limit student potential throughout their entire learning progression. Imagine getting the same feedback in your science research. Ask better questions, over and over again. Ask better questions, and never being provided the opportunity to improve your questions or apply strategies students can use to ask better questions and appropriately frame the problems they are trying to solve. The K-12 Skills Progression document on the Idaho Department of Education website breaks down the experiences students should be able to navigate to stay on track with peers locally and nationally. This document provides teachers with starting points for imagining a range of student experiences that allow students to build competency in the range of skills associated with developing questions. When laid out in this way, we can provide clearer feedback to students and scaffold more for students who find generating questions difficult or challenging students who have shown early mastery in the SEP. It becomes important to remember students often do not master a standard in a single instance. So planning several opportunities for students to flex all of their question asking skills within a grade band is critical for all students to stay on track in their science progression. If you are exploring any science standards around the properties of light, I found this really cool study authored by two researchers here in Idaho Falls at the Idaho National Lab. David Hurley and Zilong Hua, among other folks at the INL, collaborated with researchers at Ohio State University and the Acoustics Laboratory of the University of Le Mans in France. This study detailed the steps these scientists and engineers took to develop a model of the microscopic structure and behavior of ceramic materials. Using X-rays and lasers, the researchers were able to map the internal structures of ceramic pellets. Dr. Hurley and Dr. Hua's team have coined this method as time-domain Brouillon scattering and believe this method could prove useful in liquids, plants, and animal cells. I'm going to stop there and say if you have more interest in putting Idaho scientists in front of your students and you are investigating the properties of light, you may reach out to an organization like the INL to see who is available to show the real investigations scientists throughout the state are investigating across the science spectrum. Now, you are probably looking for strategies to tease out the question creation process in your classroom. It should comfort you to know instruction around science and engineering practices doesn't have to take an entire class period, and you can implement many strategies seamlessly into your regular lesson plans, like these strategies that we're going to cover right here. The Notice Wonder activity at the beginning of this presentation helps place the students in charge of the question development process. This can be low stakes and allows students to generate questions realizing that they should not know all of the answers. Have students write down their notices and wonders and then have them share these out while explaining how they came up with these observations and questions. Think alouds give students critical reasoning and awareness skills. By tracking your own thoughts in question creation, maybe even drawing in the cross-cutting concepts, students can gain a peek into how they might similarly use critical thinking to produce new questions. Question starters. Some students struggle to get started, so question starters are helpful in giving struggling students just enough to map out an appropriate scientific question. TAPN, or time, amount, public, novelty. Some helpful parameters to set up around question generation when revealing answers in front of the class. By telling students the time provided for question generation, the amount of work to be completed, acknowledging that products will be shared with the class and should reflect new understandings, you can create urgency and consistency with resistant or advanced learners. And finally, Socratic seminars are useful forums for students to lead their own inquiry in science. In a Socratic seminar, students are assigned roles and responsibilities to create dialogue and discourse around any topic you may be investigating as a class. Hopefully, the understandings and strategies outlined in this video make it less stressful to bring instruction around the science and engineering practices of asking questions and defining problems to your students. Please do not hesitate to reach out to me or anyone on the Idaho Science Coach team to clarify anything about the standards.